Alright, let's do a hypothesis test. So this is a problem that I wrote, and it says that Mayor of Murphopolis is concerned that his re-election campaign isn't receiving enough donations from his supporters. To combat this, he pushes a new ad campaign in order to see if it makes a difference either way in how much money is donated. From existing data, he knows the average monthly donation from his supporter is $6.39. After running the ad for 2 weeks, he looks at a random sample of 30 randomly selected supporters and sees that the average amount of money donated among them is $6.36, with standard deviation 11 cents. Is there convincing statistical evidence to suggest that the ad campaign changed his supporters' donation amounts? Alright, so we know our problem now, and the first thing we're going to want to write down is the acronym PHANTOMS. And I'll show you what PHANTOMS stands for throughout the video, but we're just going to want to write that down so we can follow our steps accurately. And so the first step of PHANTOMS, the P, is state the parameter in question. And the way we're going to do that is we're going to write down, we want to test if there's significant statistical evidence to suggest that the mayor's new ad campaign is changing donation amounts from his supporters. Let mu represent the true average donation amount from his supporters after the ad campaign has been run, because that's going to help lead us into our null hypothesis and our alternative hypothesis, which is the H of phantoms, set of your hypotheses, which is that mu is equal to 6.39 and mu is not equal to 6.39 for the alternative. That's important because this is a two-tailed test. The key word from the problem is change, so that's why it's a two-tailed test. And we're just going to set our alpha value while we're at it, because they didn't give us it in the problem. That's our significance level. If the probability is lower than that of our test statistic, which we're going to calculate later, then that means that our alternative hypothesis is accepted and the null hypothesis is rejected. So now we're going to check our conditions. Assumptions and conditions is the A of phantoms. And the first of those is the simple random sample, which is given to us in the problem. The 10% condition can easily be checked by assuming that more than 300 Morphopolitans exist, so that condition is met. And the central limit theorem helps us assume an approximately normal sampling distribution in the context of this problem. The central limit states that if your sample is greater than or equal to 30, then you will have an approximately normal sampling distribution, which we are able to satisfy here. And this is something that I like doing. You don't have to do this, but I think it just shows the AP readers that you know what you're doing and will help save you from the possibility of any missed points, which is just writing down what our conditions actually help us do. So for the 10% condition, we have independence and a reliable standard error calculation, which we're going to do later down the line. The SRS helps give us an unbiased estimate, and the central limit theorem, again, like before, helps us assume an approximately normal sampling distribution with the parameters mu null and standard error of x bar. Alright, so all of our conditions are met, and we're going to jump to the next step of phantoms, the N, which is name the test. Like confidence intervals, which I have a video on, this is a short step, but it's very important because we need to say what we're going to do next. Almost wrote a one prob Z test there, but the test we're going to do here is t-test. And so next you do the T of phantoms, which is test statistic. And the test statistic we use here, as implied by the name of the test, is a t-statistic, which is calculated using the formula x bar minus mu null over standard error of x bar, which I'm going to write right here. It's always good to write down your formula so the AP readers know where you're at. And so the standard error here, because we're dealing with means, the formula is standard deviation of the sample over the square root of the sample size, Sx over n. And we can easily calculate that using the calculator, which I'm going to punch in right here. And that gives us a value of approximately 0.02. Our other two values that we need to calculate our test statistic is x bar, which is 6.36, and mu null, which is 6.39. Both of those are given by the problem. And we move on to calculating our test statistic. using these values, which we're going to do right here, 6.36 minus 6.39 over 0.020, which gives us an approximate value of negative 1.5. So now we're going to jump to the O of Phantoms, which stands for obtain p-value, and we are going to do that by writing down 2 times, because this is a two-tailed test, we have to multiply by 2. Probability of t is less than or equal to negative 1.5. Because without the 2 multiplication, it would just be a one-tailed test because it's only going one way. And the way we're going to write that down into our mathematical calculation is 2 times the calculator function tcdf. Write down your lower bound as close to as infinity as you can get it. Your upper bound is negative 1.5. Oops, and we have another parameter that we didn't write down, which is the degrees of freedom. Obviously, the degrees of freedom is 1 less than your sample size, which in this case is 29. And so now all we have to do is go to second distribution and enter in our tcdf values, which we wrote down on the paper. And this gives us approximately, let's multiply by 2 before we forget, 0.1444. So we put our alpha value down earlier, and now we have to compare it to our p-value. So we can see that the p-value is greater than the alpha value, and that means that we failed to reject our null hypothesis. And so what we have to write down now is the last step of Phantoms. By the way, the decision failed to reject is the M, which is make a decision, and S is state your conclusion. We just have to write a simple sentence of there's not enough evidence to suggest that the new ad campaign changed donation amounts from the mayor's supporters. Alright, we're done. Join me next time.